sequences and their special traits with their summation. So a sequence is arithmetic if the differences between consecutive terms are the same. So if you look at a sequence, the first term, second term, third term, fourth term, so on and so on and so forth, there's going to be a number d, where d will be equal to the second term minus the first, the third minus the second, the fourth minus the third, and so on and so forth, until you get the last term minus the second to last term. So if this happens, we have an arithmetic sequence equation that we can define as a sub n is equal to the first term plus this d value times n minus 1. Now, this equation is very similar to point-slope form. Well, point-slope form, you have to have a point. That's going to be your first term, n is 1, and a sub 1 is your y-coordinate. Well, normally would have y minus y1 on the left. Well, we added it over. It's right here, a sub 1. Here's the n minus 1. This is the x-coordinate, if you will, of the first point of your first term. The d is acting like your slope. All right? So you can find this d by doing the first level difference test. So if we had to find the 40th term of a sequence, 2, 6, 10, 14, 18, that's 5 terms. I have no desire to find the next 35 just to find 40. It's not recursive. We just need to create our equation and plug the 40 in. So n is 40. First term a sub 1 is 2. And 6 minus 2 is a positive 4. 10 minus 6 is positive 4. 14 minus 10, positive 4. 18 minus 14, positive 4. So that's your d value. So we can write out our 40th term sequence, a sub 40, putting the 40 in for n, equals first term 2 plus the difference 4 and times 40, the n minus 1. Well, 40 minus 1 is 39. Crunch it into the calculator. 2 plus 4 times 39, 158. That's the 40th term. We can also find the sequence, since it's technically like the equation of a line, point-slope form, we can find the equation of a line between 2 points. So we can find the equation of our sequence in this format given 2 terms. So if the 4th term is 20, that's like saying, oh, x is 4, y is 20. That's your first point. Second point, x is 13, y is 65. That's the second point. We kind of showed this in our last video, 9.1, where we're making the t-chart of the values. So let's find the slope between these 2 points. D is the slope. So second y, 65, minus 20, that's 45. Second x minus 4, 9. Divide these two. 45 divided by 9 is 5. There's d. Now, we can use this slope concept again to find the first term of this sequence. So we'll use 420 over again. Your first term, your first point is 1, comma, I don't know what the y-coordinate is. That's a sub 1. So we can do the slope formula here again, depending on how you want to work with negatives. I really don't want to have 1 minus 4 on the bottom, so we're going to put 4 minus 1 on the bottom. So 20 minus a1 on the top. 4 minus 1 is going to be 3. Multiply the 3 to the 5, and now we can solve this. We can solve this for a sub 1. Add the a sub 1 over to the right, subtract the 15 to the left. First term is 5. So there's our arithmetic sequence. A sub n equals the first term, 5, plus the difference, d, 5, times the binomial n minus 1. Another approach to this is if you're more of a visual learner, you want to see this, then make consecutive blanks for each term. So we're going out to 13 terms. I'm going to make 13 blanks real quick. All right, there they are. So 4th term is 20, so count over. 1, 2, 3, 4, put a 20 there, and hopefully this is 13. Put 65 over there. Now, we know that the difference, if you add the d value to 20, that gets you the next term. So if I do this for each consecutive blank, I will figure out how many d's I need. And believe it or not, this is an equation. This is 20 plus d 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 equals 65, or consecutive addition of the same value is multiplication. Since there's 9 d's there, this is 20 plus 9 d's equals 65. And now solve for d. Subtract over the 20, get 45 divided by 9, d is 5. And then we can take this value of 5. If we know we're adding the 5 going to the right, well, then to the left, you must be subtracting 5. So 20 minus 5 is 15, 15 minus 5 is 10, 10 minus 15 is 5. Or if it's too long of a distance, just count up how many d's you have to subtract, multiply that to negative 5, and then take the 20, in this case 3 times negative 5 is negative 15, 20 minus 15 gives you the 5. That's your first term, and there's your sequence function. Quit bouncing back and forth here. All right. Now, next, we're going to talk about arithmetic series. We're going to start adding up all these terms in this arithmetic sequence. So I want you to pause the video just a second. I want you to add those numbers together, 1 to 100, without using a calculator, no pencil and paper. Everything's done between your ears. All right? Just pause the video, and when you're ready to figure out how to do it, and if you got the right answer, we'll check it, turn it back on. Okay, welcome back. So here's what we want to do. We want to group numbers together. Most people will go 1 with 99, make 100, because it's easy to add up the hundreds. 2 and 98, but that's not a good plan. What you want to do is take the first number and add it to the last number. That's 101. And then if you take the 2 and add it to the second to the last number, 99, that's 101. 3 plus 98, 101. 4 plus 97, they're all 101. And since I'm taking 100 numbers and grouping them together in groups of 2, there's 50 groups. So that's 101. That's the sum of all the 2 numbers grouped together. There's 50 of them. Multiply 101 times 50, 5,050. That's the sum. Now, if we try to turn this into a formula, where did the numbers come from? Well, the first term was a sub 1. The last term is a sub n. So we have to have an a sub 1 plus an a sub n. Then we got to figure out, well, where did the groups come from? Well, there was n number of terms, and we put them in groups of 2. So n divided by 2, that was our 50. So we're going to take the n over 2 and multiply it to the first term plus the last term. And this capital S sub n means what is the sum of the first n terms of a particular arithmetic sequence. Now, keep in mind, first term, last term, n. Those are the same variables in your sequence function, a sub 1, a sub n, n. So these two have to go hand in hand. They have to be with each other all the time, because when you're working with sums of arithmetic sequences, you might be missing the a sub n. You might be missing the nth term, and you need this sequence to find it. So for example, find the 150th partial sum. Okay, that means the sum of the first 150 terms of this sequence. So we need this formula, S sub n equal to n over 2 times the a sub 1 plus a sub 2, where n is going to be your 150, so we'll put 150 there. A sub 1 is 5, we're going to put that there, but we don't know what the 150th term is. We don't know what a sub 150 is. Okay, in comes our sequence formula. A sub 150 is going to equal the first term 5 plus, okay, now we need to find the d. So 16 minus 5, positive 11. 27 minus 16, positive 11. 38 minus 27, positive 11. 49 minus 38, positive 11. Your D is 11. I have everything. So A sub 150 is equal to 5, the first term, plus the 11 times the 150, that's your N, minus 1. Go to the calculator, crunch the numbers, it's 1,644. Now we know what N is. We do not put 150 for A sub N. You have to find the 150th term. Only the 150 goes in the numerator over 2. Well, 150 divided by 2 is 75. 5 plus 1,644 is 1,649. Multiply those two together. The sum of those 150 first terms is 123,675. Okay, we have to find the sum of 1,000 plus 950 plus 900 all the way down to 250. Okay, well, we know the first term. We know the last term. My only problem is I don't know how many terms this is because they didn't give me what's in the middle. They gave me this dot, dot, dot. All right. So let's see. I can find the difference. 950 minus 1,000, that's a negative 50. So now we are counting down. So this D can be negative. That's okay. So I have the first term. I have the D value. I don't know what the N is, but I do know what A sub N is. It's 250. So 250 is equal to, that's the A sub N. We don't know the N value yet. That's okay. Is equal to the first term 1,000, not plus D, but now minus 50, because it was negative, times N minus 1. Okay. Notice my equation only has the variable N in it. We can solve for that. So everything on the outside of the parentheses has to go. So subtract over the 1,000 to the 250, that's a negative 750. Divide both sides by the negative 50. Okay, dividing by negative 50 into a negative 750 is 15. Add over the 1, N's equal to 16. Perfect, I have the N. I have the first term. I have the last term. I can find the sum. 16 over 2. This is going to be the 16th partial sum. There's 16 terms here. So S sub 16, again, remember that tells us how many terms we're adding. 16 over 2 will be 8. 1,000 plus 250 will be 1,250. Multiply that together, that's 10,000. Sound good? All right, so we'll pick up the geometric series in class on Monday. Have a great weekend.